Hello everyone. Today I'm going to showcase my research topic and my research project, which was based on AI powered NLP network analysis tool. So what this tool basically is, it is a AI powered Wireshark tool in which you can give user prompts like let me show you an example like this one. You can give any user prompt and it will in return give you a detailed summary or a detailed analysis. It will do a deep packet analysis on that PCAP file, and then it will give you an thorough analysis and thorough attack patterns and whatever you ask it. So this is the first example, like this was the PCAP file which was found in an attack. This is containing many of the onion trafficking and onion traffic, and also many of the attacks like nmap scanning attack, and many more attacks are found in this PCAP file, which was found in internet. And this was a case study given to do snort rules, the IDS rules. So these are my this is what my AI has given in return. Like there is a port scanning happening on this IP addresses. From this IP addresses, there is some P2P traffic from this to this, and and it has also given the full onion traffic URL. This is the onion link which was provided by it. And these are some general observations. No significant DDoS attack patterns or SYN flood attacks were found. And also, now one more thing, like I had said that give me recommendations in my prompt, right? So it gave me this some recommendations which I have written below. These are the recommendations which it has provided, which I now what I can do is I can use these recommendations and apply some snort IDS rules, or apply this to my firewall. So this way I can be this way I can prepare myself defensive wise to prevent these types of attacks. Like it has given that investigate port scanning, monitor P2P traffic. It has given all the steps, like further steps. It has also given that do a host review on this further, because this is the one that is compromised, right? It has also said that IDS ensure your IDS properly configured and updated with the latest signature to detect wide range of threats, because this was found in wild. That's why it is saying that make sure that your IDS is updated to detect all the range of attacks. So how did it do all this? So firstly, in my tool there are mainly there are 30 plus functions like this, like detect anomaly traffic patterns, detect analyze patterns. You can say somewhat this is like tools calling, what MCP does, but I have written and I have hard coded that in my code. That's why it is like this. And it will look into all that functions, and then it will run those functions, and that's why it is showing completed function. So it will run each and every function and it will gather all the data. But those are like static functions, because it has some default cases like tshark cases. So that is not like the proper appropriate method to do deep packet analysis when you are doing with AI. That's why what I am doing is I am also generating AI based commands. So firstly it will try to do firstly it will try to generate a command. It will run, and because this command was an error, as you can see, so it will try to do it again, and this will happen in an agentic loop. It will try to score itself also, like result given was 7 points, and the explanation why this 7 point was given, and it will try to improve it. It will try to do the self correction method on its own, and it will try to improve its prompt every time, and it will try to do the further more deep packet analysis, and it will try to go till 10 score. It may go, and it may also not get the highest possible score, but in this case the 7 was given, and 7 is the best possible we could have written, so we have written. and then it will do a basic analysis, like this data is nothing but these packet lines. This is what it has collected. As you can see, this is what it was this is what it is it has collected. This is the frame number, this is the date, time, and this is all the packet detail, right? So based on this, it will do a analysis and it will give us this full output. Now let me show you some more examples, like okay, this is a beacon attack which we are going to perform later onwards. That's why I am not showing you this example. Okay, this is a very good example. This is also taken from an internet malware PCAP file, and in this you can see, like the prompt is very generic, very non-technical prompt. As you can see, there is not a single technical term mentioned other than SMTP. So let's assume that this PCAP file was given to a police officer, and what police officer has done, he has written, can you show me SMTP traffic in this, and if there is then show me line numbers on which data is sent over. This was the prompt given by a police officer, and it is very non-technical. There is no technical terms other than SMTP in this. So as you can see, it has gathered so much data with this, like it has also gathered that these are the line numbers, and now a analyst or a forensic guy only has to do is go to these line numbers, because he knows this is SMTP traffic and he can do further analysis on this based on these line numbers. He don't have to go through each and every packet and find out where SMTP is there or where the data is sent over, right? It has also scraped these emails. These are the emails that are involved in this conversation, and this message was in base 64, by the way, and it has also decoded the message plus subject. This was the subject, lunch next week. This is the message, sorry I can't do lunch after all. Next week heading out of town another time, N. This is the sender, from and Derkover. So it is very context aware, and I have written this in my research also, that it is very context aware, and it can reconstruct all the context based on the analysis, based on the deep packet that we have done, right? And the best part about this is it is auto healing and auto recorrecting on its own. Like you can see the this time it has selected these functions, extract emails, and it has only selected one function because it was only relevant one function in my tool calling, right? And then it is doing error, and then it is doing executing commands. It will generate new commands, and it will do the execution, and it will give a score on its own, right? So in this, the best part is that you can see there are many errors, because first time error, second error, third error, fourth was a successful, it gave itself 6 points, then it was again an error, then it solved its error and it gave a result of 6 points, then it improved and it gave 7 points, and then it found out that score is very floating because we are only getting till 7 points, right? So it said that now we can proceed with analysis, right? And as you can see, there are many errors in analysis. It was not perfect. It was like, I have also written here that initial first two attempts were just error. It was just trying to figure out what command should I use and what command should I not use, right? So and third or fourth attempt, it tried to figure out where the data was, SMTP data.fragment, where this was, it tried to figure it out on its own, and then it figured out that no, SMTP.data will give me the best text-based extraction, right? And then on the final attempt, it got the very best optimal extraction parameters, and that's how we are on this. We got this very good result in return, right? Now let me show you another example, and this was just one single word. So as you can see, you can say that this is a single short prompt, right? We have just given one single word, summary. Okay, And in this summary, it has given that these are the IP addresses which are involved in this conversation. These are the port numbers 447, 49470, 53, 443. These are the ports that were involved, and it has also recognized the HTTP pattern, right? Including request for NCS IText, and then from this URL it has also tried to download this zip file from dckristen.com solar php, and it has also tried to download the Microsoft update because it is saying ms download update v3 static. So as you can see, it is very context aware, because it can look into that ms download, and it has correlated that this was the URL www.download.windowsupdate.com, and these are the PNGs, and these are downloaded, and it is also giving a somewhat basic summary that these are the port ranges where seemingly with dynamic ports these are the port ranges where the traffic was most seen, right, based on just single one prompt and one word prompt, right, summary, which is very generic because we have not given any detail to it. And this is all the details about it. So where you can use this so you can use this tool in network troubleshooting, like give me TCP three-way handshake to this website. It will give you all the details about that TCP three-way handshake. You can use this in security incident investigation, like we saw in SMTP. You can use this in threat hunting, like what are the IP addresses that are communicating, what are the suspicious IP address that are communicating. You can also do forensics investigation, like we saw in the summary prompt and the SMTP prompt, and in the snort file case prompt. So these were the examples which I have shown in my research paper. Now I'll show you a demo of this tool. Like we are going to do a C2 server attack, and these are my two EC2 instances that I have created on AWS, and this is my Windows PC, and this will be my C2 server. Okay, so firstly what I have done is so firstly in the C2 server I have installed the XFCE desktop environment, and I have done the RDP, right. And now what I'm going to do is start the Sliver, and I have written some notes for myself. So first we have started the Sliver server, then we are going to start a MTLS listener. I'll put and we can check that it is listening on 8888, right. Now we are going to generate a beacon for our attacker. Okay, I'll have to write the whole command by myself. Okay, actually these are my old beacons which you are seeing here. We can also do beacon RM, so we can do beacons RM, and this way we can remove those beacons, because I had tested this on the Windows, that's why it is showing the old beacons running. So now what we are going to do is we are going to generate a new beacon for ourselves, right. Okay, I'll explain you what the command does. So firstly, this is the generate beacon command, right. Generate beacon MTLS, because we are going to do this on TLS communication channel, and this is my private IP address of this C2 server. As you can see here, this is the private IP address 172.131, right. Okay. Okay. this is the private IP address, and we have started a listener on 8888. That's why we are going to use this, and this is the OS Windows architecture AMD 64 and format is exe. So this will generate a beacon for us, and which we are going to detonate on our compromised Windows system, and it has generated a beacon modernpants.exe, and here I have running HTTP server to transfer the beacon over to Windows PC, right? And we are going to refresh, and we can see that this is the beacon modernpants.exe, right? It has also shown it on the terminal, and we are going to do keep on this. Okay, now once we try to execute, just look down at this sliver prompt. It will give a reverse shell of that beacon. Okay, it is asking if you want to run the unknown publisher application. So we are going to do allow run, and it has generated a beacon. So now what we are going to do is we are going to use this beacon. So you can do use and just starting 3 characters, right? Use ACC, and then we want an interactive cell in this. So we are going to write interactive. So what this will do is it will send a connection over to our Windows PC, and it will say that I want I want a cell connection, I want a interactive connection. So once a new beacon will come in 34 seconds, it will give a interactive cell to us. So currently, if you see in sessions, there are no sessions because the old sessions were deleted, right? So now again, if we do beacons, it will say 19 seconds. After 19 seconds, we can see that it will generate a new session for us from this Windows PC. 8 seconds is more remaining. Okay, for some reasons it is not giving the reverse shell. Okay, so it has given the session, as you can see, session A93. So now what we are going to do is we are going to use this session. So we are going to do use A9, and active session is selected, right? So now we can do simple cell. Before doing that, we are going to start the packet capturing, right? So on Ethernet 2, and this is capturing all the packets over the Ethernet. And now what we are going to do, we are going to run the cell command. This will give a cell inside of that Windows. We can do clear, and we can do who am I, and as you can see, it is saying EC2 AMZA administrator. This is the local domain that was provided by AWS, and this is the administrator user. Now we can do anything in this, like we have prawned the system, right? So now we are going to save this file. We are going to save it as evidence file, and we are going to change the save as type to PCAP file, right? Okay, that evidence is saved. Now we are going to start a simple Python HTTP server to receive that file for further analysis. So I have started the HTTP listener, and once we refresh here, as you can see, we have got the evidence file.pcap. We have just downloaded the file. Now let's go to my application's local environment, which is a Next.js application, and the code in the backend, it is written in Python. It is running on 5000 port. It is simple fast API server, right? Okay, so in this we are going to give the evidence file.pcap which we have currently generated, and we are going to write a simple prompt like summarize this file for me and do so as you can see, I have written a simple prompt, summarize this file for me and find if there is any kind of attack happening in this, right? So it will try to do the analysis. Firstly, as I said, it will try to decide what kind of functions to use in this. So because I have given a very big big name like attack happening, that's why it is going to select many of the prompts, many of the tools and many of the functions which I have given, right? So if we go up and as you can see, it has run get pcap summary because we have written the summary keyword. It will do get protocol hierarchy, get IP addresses, get bandwidth usage, and it will try to detect DDoS attack. These are all the functions which I have statically created. Now it will try to do command generation and it will try to evaluate itself. Okay, so okay, so I'm getting a model overloaded, but as you can see, I have I have generated 3 commands and all 3 were in error prone, right? Still we have got the output, and it has summarized that there is many TLS and TCP internal and external IP addresses involved, and it has also the analytical identified multiple instances of potential TLS beaconing activity because it was a TLS beacon, and I never mentioned that is there any beacon attack, right? Still it gave me that there is an TLS beacon attack happening. This was the internal host and this is the external IP. Now if we see in the EC2 server, EC2 page, we can see that that is the public IP address which is provided like in the first paragraph of the result, and we have also got private address, and private address was obviously given because the reversal was in private address, but we have also received the public address, so this is good, right? Now we'll do furthermore looking into it, furthermore we'll look into it, and it has said that there are many firstly it has detected that there was an HTTPS connection, RDP connection, because we have connected over RDP, that's why. Then it also gave that there are many unusual ports like 507, and these are basically the sliver ports which sliver uses to communicate with and to gain the reversal, right? And you can see it has also given the statistics like total 1360 frames were there, 455 KB of data was captured in this. It has also, now it is giving the analysis of potential threats and anomalies. Look into the point that it is saying potential, it is giving a false positive report because it can't be 100% true based on some level of deep packet analysis, right? So firstly we have received the external IP address which is the public facing IP address, and this is a big thing. You cannot get this by just doing basic Wireshark analysis, right? And these are the internal hosts which were observed, uh, and it is saying that no SYN flood, no port scanning was found, no significant DDoS attack was found, no missing bandwidth usage was found. Infection, so yes, infection is also there because we have infected this system, right? And conclusion, so this is a small TLDR for everyone that potential TLS beaconing from this external IP address to an internal host, right? This was noted. It is also given the recommendations. We have not said that, but it has given because there was an attack pattern found in this, right? So it has given an recommendation that investigate further into these IP addresses. Is this a known legitimate service provider? If not, it should be treated as malicious. It is saying that quarantine or isolate the internal host for in-depth forensic analysis, and review internal beaconing. Investigate the internal host this to understand the nature of communication over ports over this. And as you can see, it has also shown the 8888 port, which was a internal thing to us, to the Sliver C2 server, right? Also, it has addressed that there were many tools error during tshark command generation, but still it tried to generate this good of an result.